Elon Musk's reaction to the first images from the James Webb Space Telescope. Wow, just wow. This is incredible. The first image from the James Webb Space Telescope, and here it is. Look at that. Galaxies stretching out to the very edge of time itself. Can you imagine that? The scale, the vastness of it all. It's mind-boggling. You know how people often try to conceptualize space by saying, imagine a grain of sand held at arm's length. Well, take that grain of sand and imagine it covering this entire portion of the sky. That's what you're looking at right here, captured by the James Webb Space Telescope, 1,000,000 miles from Earth. This is truly a remarkable moment in the history of space exploration. Now, just to clarify, you might notice some spiky structures in the image. These aren't distant galaxies or stars. No, they're just diffraction spikes. That's an artifact caused by the internal structure of the telescope itself. But don't focus on those. Look at the rest of the image. Look at those distant galaxies, some of them forming beautiful arcs across the field of view. These galaxies are incredibly far away, and what you're seeing is the result of gravitational lensing. They've been warped by the immense gravity of a massive cluster of galaxies sitting in the middle of this image, a phenomenon known as gravitational lensing. That's a glimpse into how gravity can bend light and space itself, showing us the universe in ways we've never seen before. This is no ordinary snapshot. These images are the culmination of decades of work by scientists, engineers, and astronauts, all working together to make something this extraordinary possible. It's NASA, it's Northrop Grumman, and countless other teams and individuals who've contributed to this. They've literally brought the universe down to Earth for us to observe. And what we're seeing is truly groundbreaking. This is the type of exploration that brings us closer to understanding our origins, the cosmos, and the ultimate fate of the universe itself. Amazing, absolutely amazing. Now you might ask, what exactly is this James Webb Space Telescope? What makes it so special? Well, it's the next generation of space exploration. Hubble was groundbreaking in its time, but Webb is designed to go even further. It's going to reveal the universe in ways we've never imagined. When Hubble was first launched, it was revolutionary, but now we're entering a new phase with Webb. It's a whole new level of technology, and that's saying something. The design of Webb is like nothing we've ever done before. To give you an idea, it's so large that it couldn't fit inside the fairing of a regular rocket. So what did we do? We had to fold the mirror, like the petals of a flower, and launch it in that compact form. Then, once it's out in space, it unfurls. It's a brilliant piece of engineering, no doubt, but it also comes with some risks. Launching something this delicate is always a gamble. There's a lot that could go wrong. But in the end, the payoff is going to be astronomical. And the whole point of this telescope, it's designed to observe the earliest galaxies formed after the Big Bang. We're talking about seeing galaxies as they were born, nearly 13.8 billion years ago, in the very early stages of the universe. That's why this telescope is tuned specifically to infrared light. By observing infrared wavelengths, Webb can penetrate dense gas clouds and see the birth of stars and planets. In other words, it's designed to peer deep into the universe's past. Think of it like this. You've probably been in foggy conditions before, and you know how headlights can sometimes make things worse because the blue light scatters into the fog. But if you use yellow or amber lights, they cut through the fog. Well, infrared works even better. It can pass through clouds of dust and gas that visible light can't. So, with Webb, we're able to see things that were previously hidden from view. Things like star formation, planet formation, and even the building blocks of life. One of the things I'm most excited about is Webb's ability to look at the first galaxies that ever formed after the Big Bang. We're talking about tracing the very beginning of the universe, looking back in time to see the first stars lighting up the cosmos. The birth of galaxies, the formation of stars, and the origins of elements. We're getting ready to see all of that unfold before our eyes. It's like stepping into a time machine that can take us back to the earliest days of the universe. But that's not all. This telescope isn't just about looking at far-off galaxies. It's also designed to study exoplanets, planets that orbit stars outside our solar system. We're especially interested in planets that could potentially harbor life. One of the most common types of planets we've found in our galaxy is a type we don't have in our own solar system. These are planets known as super-Earths. We don't know much about them yet, and that's what makes them so intriguing. Are they potentially habitable? Could they support life? Or are they something completely different? Webb is going to help answer those questions, and that's one of the reasons I'm so excited about its capabilities. The telescope isn't just going to take pretty pictures, it's going to give us the data we need to understand the universe on a fundamental level. One of the key techniques Webb will use is spectroscopy. Spectroscopy is the study of light as it passes through a prism or other filter, breaking it into a spectrum of colors. These colors hold vital information about the objects we're observing. It's like looking at the rainbow after a storm. But this rainbow is going to tell us what stars are made of, the chemical composition of distant planets, and even if those planets have conditions that could support life. Spectroscopy gives us the ability to decode the light from distant stars and galaxies, revealing their secrets in ways that were previously unimaginable. When I think about the future, it excites me because this is just the beginning. We're on the cusp of a new era of discovery. Webb isn't designed to find life directly, but it's a crucial step toward understanding what makes a planet habitable and where we might find life elsewhere in the universe. In fact, the next big telescope after Webb is going to be focused specifically on searching for life. Imagine a future where we find another Earth, a planet where life is thriving, where we might even find intelligent life. If you're in high school today, you'll be alive to see that discovery happen. Now, let's talk about where Webb is positioned in space. It's not like Hubble, which orbits the Earth. Webb is located in a place called the second Lagrange point, or L2. This is a special spot in space where the gravitational forces of the Earth and the Sun balance out, allowing the telescope to orbit the Sun in a stable way, but without being affected by the Earth's shadow or its atmosphere. L2 is about 1.5 million kilometers from Earth, about 4 times the distance from the Earth to the Moon. It's an ideal location for an observatory because it gives Webb an unobstructed view of the universe, away from the light pollution and interference caused by Earth. The position at L2 also means that Webb will always be pointed away from the Earth, which is great for observations. But that's not all. Webb will be in constant communication with Earth, sending back data that will be analyzed by scientists across the globe. The data from Webb will change our understanding of the universe, and it will continue to do so for years to come. The first 6 months of Webb's operations will focus on calibrating its instruments, making sure everything is working as expected. After that, the science program will begin in earnest. There's always a chance that Webb might find something unexpected. One of the most exciting aspects of this mission is that we don't always know what we're going to find. The Hubble Space Telescope made incredible discoveries simply by pointing at random patches of the sky and seeing what was out there. Maybe Webb will do the same. Sometimes, the most important discoveries happen when we weren't even looking for them. But for now, we have a detailed roadmap of observations that Webb will follow, and the telescope's schedule is already packed with exciting missions. Planetary scientists will be looking at our solar system's objects, studying asteroids, comets, and even the planets themselves. Astronomers will be studying distant stars, galaxies, and black holes, pushing the boundaries of our understanding. And we'll also be studying exoplanets, searching for signs of life in other worlds. In the end, Webb is more than just a telescope. It's a leap forward for humanity. It's a tool that will help us understand the very origins of the universe and answer some of the biggest questions we've ever asked. Where did we come from? Are we alone in the universe? What's out there, waiting to be discovered? These are the questions that Webb will help answer. So, let's keep looking up. The future of space exploration is here, and it's incredibly exciting. The James Webb Space Telescope is just the beginning.